Everything is on. This is our second round, or how do you call it? How do people nowadays in podcasts call it? Round two?
Maybe.
Which podcast, by the way, you listen to yourself?
I listen mostly to Diary of the CEO. I think one of the most popular podcasts ever. But they talk about like general things. They talk about anything in life.
How is it called?
Including AI. It's a diary of
Diary of CEO. I'll write it down.
DOAC. They spell it. So, but they had quite a lot of AI topics as well recently because it's such a like life transforming thing that is happening nowadays. Most of the people who were speaking there about AI, they were pretty negative. They were about giving a lot of warning signs that actually that we will be in control of AI. So the general intelligence will take over the world, and we need to act now. Basically, that was the biggest message there.
That's how Jan Tallinn thinks as well, right? Estonia. Yeah. I mean, there's some truth to that. Yeah, but. By the way, good time probably for Jan Tallinn. Anthropic raised like 30 billion at 350 billion evaluation, something like that. Someone will correct me in YouTube comments. But maybe for for the listeners, maybe you can just spend 3 minutes introducing yourself. We talked already at the podcast, so feel free to check out the first round. But maybe yes, you could introduce yourself so people know.
Yeah, my name is Anton Keks. I'm 25 years in software development professionally.
A little bit.
Yeah, I was developing code before that also on my own. And actually, I find it pretty awesome to meet other people who were trying to do their own software development before going to university or something. Usually those people who really love the profession and not only like do it for money. And now when we have this AI transformation, that even more makes sense, but we'll talk about it more. So 15 years ago, I founded a software development company called Codeborn that I was running for 15 years. I quit last year, in end of last year, because wanted to do other things. So 15 years is a pretty long time to do something. But I built a really good team there who were like following agile principles and extreme programming and very like a good engineering culture. But now actually it's to be seen what will remain of that in the coming years with the AI. So I think none of us knows where we're going exactly or where we are going to end up, but easy to predict what will happen next month, pretty hard to predict what will happen next year.
That's true, yeah. But what do you think if we talk about this AI transformation in software engineering? And I especially would like this talk to be useful for different kind of type of people, right? First, thinking as myself or as an engineering executive, I think it's important to navigate today's change, right? Because we have to make decisions like, who do we hire? Even what's the hiring pipeline? What's the hiring interview looks like today? But especially probably it's important to navigate this change for usual engineers, right? Like what matters today, what skills matter still, and what fundamentals haven't changed really, and what has changed and how you need to adapt. And kind of the answer probably is both, right? You need to know strong fundamentals and adapt to the change. But maybe we could explore that. But from your side, I'm just curious, who do you believe could benefit from this podcast? What would be our target audience for today?
For today, maybe like I don't know, people who are interested in like other people's opinions, because like there are a lot of opinions nowadays, ranging from like very hype related, let's like do everything with AI and software development does not exist anymore, to the people who are very skeptical. Like actually the other founders of my company Codeborn, they are pretty skeptical. They're in their 50s. I'm younger than them, and so I'm not that skeptical, but I think that we should find like the very pragmatic approach there. We cannot just sit and ignore it for a long time, I think. a lot of companies. I was talking to a lot of people recently because because I quit my job, and a lot of people are actually worried, especially the companies who actually don't have their products, who are doing the software development as a service, like I was doing. They are actually think that they can go out of business if they will not be vibe coding everything right now already. And but I also heard quite a few of the bad stories when going too fast with the vibe coding creates such a mess that nobody can maintain anymore, not even the agent.
Yep.
And so
I think our perspectives will be very interesting for the audience because, like, you've been in the, I don't know, should I call it outsourcing or software service, software as a service?
Usually it's called the consultancy.
Consultancy, right?
Because actually I was never doing only the software. So it was always, when I was talking to customers, it was always about finding solutions which are not always in coding, not always with software. And that skill actually is not going away.
Yes.
The good part of it.
As I like the saying, now with AI coding agents, people realize that coding was never a bottleneck in software engineering.
Yeah, that's true. Yeah.
And on my side, maybe someone don't know, I'm a VP of engineering at Pactum. So Pactum is Series C startup. We do autonomous negotiations and agents for enterprise procurement. So I think it's going to be interesting to see these two perspectives. And I'm actively myself. I'm hiring engineers. I'm also, doing performance reviews, evaluating how we need to incentivize engineers thinking forward, like what skills matter, what skills don't matter. And of course, we do it all being grounded in the business reality, because as we know, for startups, it's not easy anymore that you just have money and you do whatever you want. It's very still strict. You need to invest, like make your bets where you invest time. And also there are strict engineering budgets, and you have tight constraints.
But Sam Altman says that sooner or later there's going to be a $1 billion startup with only one person in it doing vibe coding. I don't quite believe that.
Yes,
because
I think it honestly depends on the scene. I'll give an example. Pactum is heavily B2B and like heavy B2B. It's business to enterprise Fortune 500 businesses, right? So it's very hard to not have humans there, because you go and talk to companies like, Rolls-Royce, BMW, you have meetings with these kind of companies, and you need people for that. You need, So I think in this sense, if you're a B2B, well, people are not going away for sure. But even in B2C, I think B2C is more representative example here, right? Because you might be able to automate some things if it's purely B2C.
If your service can be automated 100%, if somebody can register online, use your service without like any manual work, maybe, but still it should be a really simple business. Like, for example, Twitter. Twitter is a very simple thing. And actually, I saw a tweet recently that Twitter used to have like thousands of engineers. Now they have only 30. And 30, even without AI, I think it's a perfectly reasonable team size for such a simple product.
30 is nice, I agree. And especially, as you say, for such a simple product.
It's a simple product, so all the complexity there is in the scale. So basically what those people are dealing with. But you don't need thousands of people. You never needed thousands of people. And I'm happy that now with AI, people finally start realizing that. So just hiring too many people does not get you anywhere.
I agree.
People, of course, think that you hire 10 people who will, each of them will be running 100 agents in parallel, and you will also make everything work. But it doesn't work that well.
It doesn't work this way, But maybe, what do you think if we start exploring, I think maybe the most pressing question is, for usual engineers, and maybe we could discuss software engineers and senior software engineers, how to navigate current space, like what to learn, what to focus on, how to stay relevant, what skills matter even more, what skills don't matter or matter less today. So maybe, what do you think if we start from this discussion?
It's a good start.
So like, for example, like Kent Beck made a good article called Programming Deflation. I don't know if you read it, but he explored this kind of topic, like what skills matter. But maybe you want to give your perspective on this.
Yeah, I think all the skills that mattered 2 years ago, they still matter today. So I'm actually doing guest lectures in universities, and students already for a couple of years, they were coming to me after the lecture and saying like, do we have to learn anything at all, or like where we are going? And my advice was always like, of course, you need to learn the fundamentals, because right now I still see that the agents, coding agents, they can speed up senior developers who actually know what they are doing, who know what do they want to achieve. And I think they're actually bad for the junior developers who just get distracted. They get overwhelmed. They don't learn anything, because if something is done for you, you probably will not, like if you're not typing it by heart with your own hands, you're not learning it. And if you're not learning it, maybe you can be like the like very high level, but high level skills also, they mattered always. So I think that never software developers who were like blindly doing what they're told to do, like, okay, I will have this Jira task, I will implement it and forget. So these kind of developers, they were not useful also like the previous years. They were just, I think those kind of people are being replaced by the agent, because if you need somebody to tell you exactly what to do and then you will do it, then you're basically an AI agent.
So we don't need coding monkeys, right?
Yeah, if you want to actually think on a higher level, and what AI still cannot do well is actually think on a very higher level, take the whole system into account, all the integrations, complex stuff that exists in real world. So AI is better nowadays for greenfield projects, for when you're like starting everything from scratch, you're not like working with anything else outside. Then it's easier. You can like speed yourself faster, but still you need to you need to have the skills of having the big picture and actually finding the right simple solution for the problem. And you need to be able to define problems also sometimes, which is, you can use AI again for help to like to brainstorm, but in the end, AI is not replacing those skills.
And I just want to confirm that and say that in Pactum, we still have a system design technical interview. Well, our first level is a coding interview. But even in coding interview, we try to mimic the real problem-solving skills. We don't have the lead code type of interview where, I don't know, you have to implement red, black binary search tree. But we have like a simple programming task that gets increasingly more complex, but where you can figure it out if you just think hard enough. But then the second stage, we have system design interview. And yes, we are looking at skills like, we have some kind of task there, open-ended task. But we evaluate skills like testing, like testability, ability to create kind of modular components, modular testable components, right? Thinking about architecture, also navigating all this while remembering about business requirements that were given in the beginning, right there, or like ability to ask questions. So in this sense, I just want to say, yes, this doesn't go away, and it's still being confirmed by the fact that these skills are being tested during the interviews today. This is not going away. Even in companies like Anthropic. If you go to Anthropic today and you would want to work on cloud code, you would need to have these fundamental skills. And then, of course, on top of that goes product engineering and using how to learn, how to use AI, learning how to use AI. But the fundamentals don't go away. And I think I would just want to stress it for people who are early in their career, that these skills are still relevant, and you would do yourself well to double down on these skills and maybe less on some framework skills. Like, rather, if you would have to pick rather to learn API of some library or like Spring, or focus on fundamentals, because library details is definitely the skill that matters less, because this you can learn fast.
I agree. And actually, if you know how to use one framework and you understand like fundamentals, like you say, then it's nowadays AI will help you very quickly learn another one, because you will just ask like, I know like how to do this thing in this framework is like a really like well automated nowadays. So now if I'm like, for example, also using a new framework or something, I just if I don't remember how to do it exactly in this framework, before I would Google, I would go through Stack Overflow, that would take a lot of time. Now I can just tell the AI that I need to do exactly that in these constraints and here in this code base. And most of the time it gives like 90% okay solution that you need to fine tune. Regarding the skills, like people say nowadays that, yeah, we will not be typing syntax that much, but I still think that even the attention to detail is something that software developers need to have. Like there are some people who plainly don't see. They look at the code, they don't see errors. They don't see like misplaced semicolons or like curly braces or whatever. And I think this is also a skill that AI will take away from you, but be able to spot quickly if AI also is doing the right thing or not right thing. It's very important, and for that you need to be also typing and reading this code, and the attention to detail still matters.
Maybe if the way I think about it, but I want to discuss it with you. So the way I see it is that why vibe coding doesn't work, right? Because if we talk about any serious business and the software that powers this serious business, right? You have a code base or multiple, but you maintain it today, and you want to maintain it 1 month from now, 2 months from now, and 1 year from now. And of course, it will get more complex and more complex. And the whole point is that you want to keep the maintainability of the code high, meaning it should be easy to change and refactor, so to adapt new business features and use cases, right? And this is exactly the skill that where you want to optimize your fundamental knowledge for. This is how I view it, and this is why vibe coding doesn't work, because it's a snapshot in time code that produces the results. But if you don't know how to maintain it, this is where it will fall in the next iteration.
And usually, if you vibe code, it will work as a worst possible engineer who will be only adding stuff and adding stuff and adding stuff, never refactoring, never removing stuff. So I think I was a big fan of craftsmanship, and there is a craftsmanship manifesto, and I was teaching a lot about that. And but the fundamental thing there is that to get more productive as a developer, you need to know what not to do.
Yes.
Not vice versa. And with vibe coding, it's the opposite. You're just throwing and throwing bunch of stuff there until it becomes a mess. Like with a lot of repetition, with a lot of stuff that then if you need to change it, it's scattered all over.
But I want to make it clear, because in Pactum we see, and I think it's true, vibe coding can be extremely powerful for prototyping. Like there is no question about that. And I want for audience not to misunderstand us, that it's a useful, powerful tool for its own context, right? When you just have a prototype, you're playing around with the idea, you just want to, maybe it's a communication tool almost. Like you vibe code something, you show it, but then when you build a real system, you pretty much disregard it, and then you start and do it professionally. And then, so vibe coding is like a powerful tool for a certain context, for prototyping, let's say, in a generalist way. But then as we move to the professional coding, we will use AI, but we don't call it vibe coding anymore. It's more, there are terms like augmented coding, AI-assisted coding, right? Where the developer engineer controls the full output of AI at any given step, and then directs it, and is responsible for the output of it, right? As if they coded it without the AI, right? Because they are responsible for maintainability of this system, right? And I think this is important. And we have like the gradient somewhere, something in between, but that's pretty much two modes people need to operate it. So that's why we shouldn't generalize everything to the vibe coding, because I think the world is now much more with AI-assisted coding.
But I think also people nowadays already talk a lot less about vibe coding. There have been too many, like there was a big initial hype,
yes.
But nowadays people realize that a person who don't know anything about coding,
yes.
they can go only like that far. So, and there is a point that when they reach it, it becomes unmaintainable, and there is no way back, there is no way forward. Basically, you get a system that probably has also some bugs, but the agents, they cannot fix it anymore. So it's just, every iteration just breaks something, and then you're like completely screwed. There are already a couple of businesses that I heard of who ended up with that. So initially, traction, getting users, cool, works until a first security bug or big security bug with like leaking all the data or getting the point of unmaintability, and that is terrible, I think.
What's your point about, by the way, product engineering as a skill for software engineers? I know it's like a term that is used in some cultures. We use it at Buckton. We say we hire only product engineers.
I always were thinking, sorry.
No, go ahead.
So I was always thinking that good developer can be anything else. So actually, a good software developer always needed to actually learn the domain they are working in from the business point of view, from the user point of view, be empathetic to the users.
And that will never be changed, right?
Yeah, and that will never change. Yes. Yeah, and maybe we will end up with just a higher level of abstraction again, because like it's obvious.
But it still will be about understanding the pains of the user, clarifying requirements, right? Having iterations, first iteration, then iterate on this, learn from the feedback. So in this sense, this loop, product engineering loop, doesn't move away.
Yeah. And then if you type all the semicolons by yourself or not, it doesn't matter that much, because the autocomplete features in IDEs, they were available for the last 15 years at least, or like 20 years. So, and actually they also sped up a lot of coding, and I even saw like a lot of spelling mistakes being propagated through all the code base, because it's like just auto-completed for you everywhere, and you don't even notice that it's spelled wrongly.
But maybe now, so we covered the basics kind of. We understand that fundamental skills don't go away. The skills of not learning the domain, knowing the product, all these things don't go away. System design doesn't go away. Let's go maybe to a bit more trickier conversation about some things that were true before, but now, well, people have different opinions about it. So things like pair programming, testing principles, right? Like TDD or other spec-driven development. There are many things, but maybe what do you think if we take pair programming? Because I think it's a very interesting concept, and they're like, we can untangle it for 2 hours if we had the time. But right, because now pretty much engineers pair program with AI, and then some still believe in the true pair programming together because it gives a value. Some people don't, and there's a lot of discussion around here. Kent Beck, by the way, also wrote about this topic. As inventor of pair programming, he wrote about it. But what do you think about it? Where are we moving there?
Yeah, just a small disclosure. I was pair programming for the last 20 years, almost 100% of the time, except for my personal projects. At work, for business tasks, we were always pair programming. And
I want to say, I learned from you a lot by pair programming with you when I was a Starship. So thank you for that.
So I know a lot about this and all the pros and cons and stuff, and I still miss it. When actually first agents started appearing, that was my initial idea. I want to pair program a bit. So because pair programming with a human, it has a lot of cons, and most of the cons are if for you, for the other person, they will learn faster. It's easier to bring people in,
onboard people.
Yeah, to onboard people and all that, and share the skills and keep the whole team on the same level and whatever. But if you're already on a good level in your project, the pair programming gives you a buddy to talk to. It gives you somebody.
Rubber duck.
Yeah, it's like a rubber duck, and that's as funny as it is. That is the biggest value, because we as human beings, we don't like talking to rubber ducks. We prefer even just nodding person sitting next to us, and we will express our ideas and we will understand it ourselves better.
Yes.
So my initial idea when agents came, I wanted to replace pair programming with them, and it's still not happening. I don't see it's happening. People now say that it kind of is pair programming with AI agent. I don't feel that, because I don't have that level of feedback. Agent is mostly like a person on practitioner. What's the right word for it? Somebody.
It's like junior
apprentice,
engineer,
whatever, like a junior engineer, yeah, who actually is sitting there, and you need to tell it exactly what to do, and then you see what they done. You say no, 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 no. You need to like adjust that, and probably maybe you need to delete everything and go another way. So this is how you do it. So the junior engineer will never argue with you. They will never tell you like, yeah, you're probably like telling me to do a stupid thing. So, but what I want from my peer programmer to tell me like, this is a stupid idea, or like, or maybe there's another idea, or let's discuss it further, or maybe let's look at it from the other side. And I'm waiting for someone to build it. I think the technology should be there right now to create a really useful pair programmer, but it's not.
Do you know what we did at Pactum? So we now are. So of course we do AI augmented coding a lot, and we are experimenting a lot with cloud code, and mostly heavily using cloud code. But what we are doing now, we really want to create a very powerful set of skills, cloud skills, but also optimizing it for, of course, for tool calls somewhere, but also for the context, right? So, and we also now have, for example, cloud skill to give us context about Pactum business, right? Or about business priorities, about business metrics. And even those things actually help. If you give cloud code your context about your domain, about your business goals, it will inevitably make better decisions. So yeah, of course, it takes a lot of architecting today to do that, but it's worth it. And it does help a bit. Of course, I think it will get even better as models get better. But yeah, having the context is very important.
Yeah, so there are very, very, very cool ideas that some people have nowadays. For example, you can take a very, like a famous person, like in a community with who are very vocal with their values, like let's say Uncle Bob, and you can create an agent who will be like, will assume the Uncle Bob persona. Yep. Will review your code from the Uncle Bob's perspective. So those people who were like expressing their ideas a lot on the internet, you can actually get them in your team for free, more or less.
Kent Beck did it for his own augmented coding loop. He said like, assume, you're Kent Beck, you value TDD, extreme programming principles, and he like and that was literally his
cool idea. So I also I'm trying to maintain my agents in D file with my values that I usually also talk about at conferences, and I like to any new projects I will commit this thing first so that the AI agent will know like how to do things. And actually with that I get much better initial results. Even like if you start on a more empty project, then you can get it working in a better way.
But let's get even deeper with this pair programming. So you believe that we still like it hasn't gone away, and we reap a lot of benefit if we still pair program, right? Two humans sitting together.
Actually, my idea is that there are a lot of cons with pair programming also. And the cons are that people get tired, people lose focus when they are not typing. If people are on a different level, sometimes they are like not, losing the idea, and they are too afraid to tell. And in this kind of situations, actually, if you continue doing that, you have just like a dummy, like a rubber duck sitting next to you, and they are not helping, and they are not learning also. So the problem is that when you don't let the other person type, they are actually very soon they can lose the focus and stuff. And actually, my idea was with AI that it should be able to replace pair programming. So, but they should be more proactive with communication. They should be more critical. So the problem also with all the chatbots that they are designed to be very supportive, and here what you want the opposite. Of course, you can probably tell it in a prompt that I want you to be critical and everything, but you need to also prepare that. So I would like to have a tool that would actually emulate also the real work as with a pair programming, because with pair programming you're talking all day.
Yes.
You're not just typing. You're not telling your agent what to do. And that's also why remote pair programming never worked really well for me, is that remotely it's not easy to have this chat all the time and this interaction and emotions and everything there. Even if you're doing it through a video or voice channel, it still somehow feels a lot more tiring when interacting with the real person who are next to you. So with AI, I guess, because AI they don't get tired and they probably can reason about your things. So you need to probably tell them, a lot about the domain. They need to be very knowledgeable. So you cannot use them as just a simple agent who sees the code base and you tell it what to do. They need to know the skills that you are saying that about the business domain and the goals and everything, so that they can criticize your decisions. And it would be ideal to talk to it with voice, and then type, and then decide when do you go typing, when not. You can ask your AI agent maybe by voice to create this function or prototype this feature, and then you will look at it. Maybe you do your own corrections, ideally at the same time. So you do with the pair programming. So I would really enjoy this kind of support. So I think that would work.
We have, by the way, in Pactum, we have some people who actually now go with these kind of mics, and it's kind of easy to turn on. And there are also nice Mac software which quickly transcribes it. So they use it as well. Sometimes they type, and sometimes they talk to Cloud Code. And it kind of works. But I understand it can be much more streamlined. And this is actually also my prediction, that these things will get much more streamlined in a year, because it's already a kind of application layer almost, that the capabilities are there.
But you know what the problem is? That most engineers, they actually don't know how pair programming works.
Yes.
If you haven't done it for somewhere where people are really serious about it, then you don't know, and then you don't know what to want from your AI agent. So you will not be getting these benefits of pair programming, or somebody will need to pre-train it, do it for you, and sell it to you as a tool that is ready-made for that, so that you can experience. Maybe it will even teach you to be the real pair programmer. I think maybe it's a good startup, because I've been Googling from time to time if somebody has done it already. A lot of people call what Cloud Code, for example, a pair programming, but it's very far from it. It's a junior developer doing coding for you.
And let's be honest, I want to even explore more this pair programming from. I want to give you my perspective, how I tried to think about it and try to kind of hopefully arrive to the pragmatic solution. But I will now say it to you, what's the approach that I've taken and incorporated successfully in some teams at Pactum. And then feel free to kind of judge and evaluate, and let's discuss. So, let's agree that the important thing in the team is not to have knowledge silos, right? You want people who ideally would be able to take any next important work from the backlog, so to speak, or let's not even call it backlog, the next most important work, and be able to do it, right? And the more people work separately for a long time, let's say we have 5 people in the team, and everyone works independently, right, on a very different topic. Let's say one works on authentication topic for 1 month, one works on some customer-related problem for 1 month. You really don't end up having a team. You have just individuals happening to sit in the same room, and then one manager who is kind of controlling everyone, like an orchestrator. And that sucks, right? So we don't want that. So pair programming, and by the way, big kudos to Kent Beck, he realized it, right? And he realized that people need to talk to each other. They need to pair. And this way, they share the business context, the problem, and then they brainstorm on the problem, right? The problem was never the speed of coding. The full power of pair programming is the insight you get while you talk to another person. You learn from them, you learn the business context, you learn the ideas, you learn problem-solving skills, and this has a huge effect. So, but what kind of solution we arrived at is we call it pairing in Pactum, but we pair on epics. And how we do it is, imagine the epic, let's for now imagine the epic takes for 1 to 2 weeks time, depending on the feature size, but ideally not more, because the more it is, then you should split it kind of, because it's too vague. So let's say you kind of split it to 1 or 2 weeks, and maybe some range of uncertainty. And what we do, let's say if it's the team of 5, we would assign Alice and Bob working on this. What we call, they're pairing on this epic. We would assign the epic owner, still one person who kind of, if there's, just to make like the final decision, not to avoid analysis paralysis. But for all means and purposes, they would both work on this epic. Pretty much, epic is just some problem that needs to be solved, right? Some customer problem that needs to get solved. And the full point is that they can decide, Alice and Bob can decide within this period while they're working on this epic from start to finish, how they work, how they're going to split the work. If they like pairing, they will pair on this. If they somehow don't like pairing, and now with AI, right, everyone can work on themselves, but they will first discuss the interfaces, they will discuss integration points. They might discuss, hey, let's sync every day or every 3 hours to kind of see where we are at, right? And let's review each other code. And now even what we call pull request reviews, but the code reviews, they become much more pleasant because you actually are in the context in the business domain. So Alice and Bob, they know how to work together, and they do it. So this is how we approached it. And now, by the way, by the finish of the epic, Alice and Bob, they wrap up by making, if necessary, also updating documentation, making a demo on Friday, for example, to the team. And then Alice and Bob will eventually pair on another epic with someone else. So they won't stay forever as a pair, right?
Yeah, that's also very important.
Yes. So now, if, for example, on the same business topic, Alice then would not work with Bob, but John, and John kind of would get onboarded from Alice on this epic or on this problem statement. But then the idea is that you do this continuous rotations, and you combine pairing with now the power of AI, where sometimes people can still work separately, but the most important thing that they work on the same problem together. And this way you avoid knowledge silos. But now, why I said this, because I want, you've been in engineering a lot, and now with all AI developments, I want you to analyze it and like, well, how would you evaluate this approach to
I think it's a good idea to pair on epics. What we learned also at Codeborn is that there are certain types of work even before AI again, which are like pretty straightforward.
Small work, right?
Yeah.
1-2 days work.
Yeah, it can be like, I would say that any work should be small, like even complex, but I would say even on a smaller scale. So sometimes there is a task that will take me maybe half an hour, and that is very straightforward because we were doing it together because we were just sitting together, and that was the approach. And but sometimes it got also boring because like it's like you just know what to do.
It's a very straightforward.
Yeah, and you just do it. So right now this is the perfect work for AI.
Yes.
Because if it's very straightforward to do, AI will do
And
it
this is
well.
where you can parallelize it, right? That's where you don't need 2 people
and you
necessarily.
actually don't need,
I agree.
You don't need to have 2 people watching that. So we were always thinking like, when do we decide which work is straightforward and which is not? Because sometimes some straightforward work can become less straightforward as you go through it, and you realize all the details. Yes. So we accepted that at some point we decided that it's much safer, better to do everything in pairs, even if some of the work is boring or easy. Now with AI, I think we can outsource more of that work to AI and just review. But if you're working on something similar and you can still have your buddy to talk to and interrupt them at any time, which is actually good thing in my opinion. Some people talk about deep focus, but I think we're losing the deep focus in the AI world with some people doing crazy things like orchestrating like 20 agents at the same time. I think it's not a good idea, definitely. But I think having this buddy for conversations and actually also teaching each other. So important part of pair programming is that when you switch the partner, they will introduce you to like shortcuts that you didn't know,
new problem solving
skills. Some skills, some maybe parts of the projects that you didn't know about.
Like, man, I learned so much from you when I was pair programming, really. So yes.
And I think that part we don't want to lose. And maybe if we will have this 100% good pair programmer as an AI, one part of the job of this AI would be to synchronize the practices from the whole project.
Yes.
Because what I found actually, which is pretty cool with AI, so sometimes when I take a junior developer to the team, I need to, some of the things I need to explain them, not just tell them we should do it like this in this project, like the well-defined best practices. But always to a person, you need to also explain why, and it will take a lot of time for them to remember it and not to forget, because next day they will again make the same mistake that you already told them yesterday. What is good about AI is that if you tell it to follow some practices, it will
Most likely
usually,
will.
yeah, most likely will follow, and you don't have to explain some of the things, because they're usually, like in different projects, there can be different ways of doing things, and AI is just blindly doing what you tell it to do. So it's easy to work with, but also it would, and actually AI agents are pretty good at discovering patterns from the existing code. So I've looked, of course, at system prompts of some of these CLI tools. I use anti-gravity mostly nowadays, but I think it does most of the stuff that Cloud Code also does. And in the system prompt, actually, in anti-gravity, it's written there, so that you don't see, is that try to follow the existing conventions, existing patterns and stuff. And that is a really good thing. It's always a good thing that every engineer should know when they are coming to a new project and onboarding there. They should follow. But a lot of people, they don't want, or they don't care, or they just still start doing stuff the old ways or whatever. So with AI, is probably with AI pair programming, it can also help maybe synchronize on those patterns. So if you will be doing something completely radically different, maybe it should remind you, hey, we have like a class here which does it another way. Like, why won't you follow the same pattern? So this is also what I want, because pair programming is very good as also reminding people of that. So when you're switching, you're like getting the whole team on the same level, on the same values, and these kind of things. And AI can help us with that, I guess. But also, I think nothing will replace completely people talking to each other. So what you are doing, I think, is a pretty good idea. So I think, I would like to know more. How well does it work?
It works. No, we've been doing it for a while, and it works very well. And I think like the most important, like this is a practice, but it reflects the principle of not having knowledge silo. So I would really encourage everyone who is listening to the podcast. You don't have to follow this exact practice, what I just described with pairing on epics. You might have other methods, but I think you would agree that it's good to ensure that there are no knowledge silos. And it's especially important today because now with AI-assisted programming, everyone might assume, or some engineering leads or PMs, oh, now let's assign this task, or like that might, even be a complex thing that lasts for 1 month or like even 3 weeks for one person to solve, and then another person to solve another thing. And you paralyze too much and you fall into this trap of people not solving problems together. So I would say, even if you don't do pair programming, but work on solving some complex business problems together, right, ideally. And then kind of you can still parallelize and work separately, but sync often, especially if it's a shared business problem. And then there are many techniques, and the one I described is just one.
And if you assign a single person, there will be a burden of code review that everyone knows it doesn't work very well, especially for more complex stuff. Maybe with AI it would work better than with people, but still, like, having people collaborate is, I think, was always throughout the history of humanity the drive of the progress.
Yes. That's why, for example, another practice we do to avoid knowledge silos, we have Friday demos every Friday. And we used to do them, by the way. First we introduced, we thought like, we don't like many meetings, right? And we first did it bi-weekly because we thought, let's not waste each other's time. But then people loved it so much that now every Friday, in some teams, they have pretty much Friday demo, where and the demo is mostly for your team members. You kind of demo what you've done. It could be even a highly technical thing, could be more product oriented, and then PMs really like it because they can give feedback immediately. And again, it's about the feedback loops, right? And then you learn from each other, and then you have different techniques for that. But the Friday demos, we learned to love them a lot.
Yeah, demos are good even for yourself, even if nobody's watching. Like we're now talking to a camera, and we don't know if there is anyone out there. It's still useful to like think about your stuff and actually try your stuff yourself and look at it from like a different point of view.
Yeah, I agree.
So I agree, and even sometimes I feel like in Codeborn we were doing like 1 week iterations with all our development, because 1 week is a really long time.
Yeah, we do 1 week, by the way.
Yeah, and I would say that like initially in Agile people were talking about like 4 weeks, 2 weeks, and I think that 2 weeks is definitely super long. And even right now I've started just a new project where I'm helping. I even feel like 1 week is too long. I want to like do the demo already after like 3 days, because like there is so much done, so much feedback could be got. So I think actually I was doing that when in some project, when you're developing very rapidly, you can actually do demos every morning. So why not? If you have somebody willing to look at it, I'm very happy to do it.
Yep. Yeah. I agree. But nice. I think we explored the area of pair programming and everything around it. I'm satisfied. I think it was and it was a good to bounce ideas here. And so we do agree that it's changing a bit, but we want AI to help us kind of pair with it effectively, right? And then still not lose the human touch and not have knowledge silos, but learn from each other and collaborate. Because at the end of the day, you're a team and you need to solve some problems in your subdomain very well together. And I think it's important not to forget that. And but about what do you think if we talk about testing? Jumping from topic to topic, but I think
testing is also a very important pillar of extreme programming, just like pair programming is. And I think there are a lot of still people who think of tests, automated tests, as something optional. And especially people from vibe coding and stuff.
But they never maintained complex systems and had to refactor those.
But it's also important to write the tests right. I still actually think like what Ken Beck also thinks right now, that test-driven development may be how we will be developing software in the future. So we will be writing tests first, or at least, or even first we'll explain the tests to the agent, and then we'll explain, like, let it implement it. Because tests, they're always safe at the net. They always have been against accidental breakage, regressions, whatever. So in my experience also, it was, if you have some complex non-trivial logic, if you don't create a test for it, so you can already think about it that it's temporary. Somebody will just delete it without realizing from your real code, and if nothing breaks, then okay, I'm done, all great. So I think they're even more important than they were before, but they were super important before also.
I agree.
So it's so difficult to say it like this.
I even call it like this. If you remember before with tests, so yeah, we agree that, and again, not to fall into this. I agree with you, by the way, on TDD. I know there are many different people who like it, who don't like it. By the way, usually people who don't like it, they never actually did it for a long time. So if you ask, actually, have you practiced it for a long time? Some people say, some people did. Like, what was this canonical discussion between Robert Martin and who the guy who created Ruby on Rails, right?
The DHH.
DHH, right, is his nickname. Like, they actually had a very fruitful discussion, right? Like and DHH, I think he tried TDD and he understood it. At least they had a good discussion. But mostly, I agree. You can do it, and you can. I view it like this: like, you have some. Let's say you have a system. Let's imagine it's in a perfectly maintainable state as the starting point. You make a change on top of it. You want to ensure after this change that, again, nothing is broken and nothing will be broken, right, further on. Which means this test, or this automated test, should be part of CI/CD. And this doesn't go anywhere, right? Like whatever testing methodology you use, be it TDD, test first or test after, you have to ensure that. Like that's at least like we can agree on this baseline, right? And so now, but if we agree on this baseline, it means that not having this test in CI/CD is pretty much, it's not an excuse anymore, because previously some people had an excuse that it takes time to write this test. Now it's just a matter of skill. If you can navigate and tell agent how to do it effectively, there's no excuse except lack of skill to do it. Like I think.
But with the agents, the big problem with agents is that it's very cheap to do boilerplate now. And of course, if you create boilerplate, it will harm you down the line, because it will be too much stuff to maintain, either for a human or for AI. It doesn't matter.
Boilerplate with tests or without?
Boilerplate with anything. So it's way too easy right now to just create a lot of code for some simple thing. And like to over-engineer it. And the same with tests. So the big problem with tests, and why a lot of people are like, even before I were like hesitant to writing it, because they had a trauma of really huge tests, which become also unmaintainable very fast. What I've seen in teams, even with human developers, they were just doing too much copy-paste in every test, and they do like these kind of test methods, which
the setup
prepare,
is like
like
this, right?
set up everything, the whole world, then do something, and then assert something, and it's not very clear what they are asserting or why, and then they just copy paste that many times, because they are also afraid of changing the previous test, because it's just too much code and you don't understand what it's doing exactly. And right now, and that was a problem before, but now it's even bigger problem. So now, of course, in my agents MD file, I have it like for every change, you should create a test, of course. I also, of course, I have there like, don't repeat yourself and keep it simple and whatever. But still, I see that AI is also having this problem, just generating very big tests for very small changes. And the test files, they grow too fast, and then it's hard to maintain them. So
I think we should control tests.
Yeah, of course.
And then by that, of course, we control the design, and by that we control the full feedback loop.
Yeah, and then that's what people were not realizing before also, is that it's very important how do you write your tests, so that the intent is very clear and that the tests are very short. You should also apply all the simplicity rules and refactoring rules to your tests.
By the way,
they are not just, if you just like do and copy paste them, they become a mess, and then somebody will just delete them, because they will have like 100 tests failing, which they don't understand. So they're
I just want to say it's so true. Like at Pactum, like I can give you an example. What we had, I once we sat together with one of our senior staff engineers, and we were analyzing like what's the next most important problem to solve. And he gave an idea that he said like, look, our tests are very messy, and we should do something about it, because it will bite us in the future. And he realized the following, that we had external system that we interacted with, the procurement system. And in our tests, of course, we mocked it. And, each setup was like, given this, return me this response. But like it was like very declarative and heavy mocking. And what we replaced it with, we realized, okay, it's not declarative. It's like a lot of boilerplate. We replaced this external system with a simple fake, which, stored the state if you post to it, and then returned in get, and like very simple fake implementation. But as a result, tests became very declarative. We removed a lot of unnecessary code. But this is just one example. But and then engineers really liked this change, and people saw how important it is to have very expressive, nice, maintainable tests.
Yeah,
and it is right. And the interesting thing is, it's still important today. This doesn't move away with AI. And even for AI, the funny thing is the following. If you maintain your system today, it's going to be easier for your AI to change it tomorrow. So actually, it becomes more maintainable not only for you, but for AI as well. Because AI, if the system gets more and more complex, it will also be even harder for AI to navigate it. But if you make it more maintainable today for yourself, you make it more maintainable for AI. And I think it's true.
Yeah, of course. And if you're keeping your code simple, it's good for yourself, good for humans, good
And
for AI, because it will just consume much fewer tokens. So with the tests, it's very important to have this fakes. There is a difference between mock and fake.
Yes.
So creating those fake things, they don't have to be a separate system that is like implementing some API. You can also usually inside of your system.
Yeah, we did in memory.
Yeah, you always have some interface that you call. So it just makes sense to make those reusable components in tests that you would reuse. And of course, nowadays in your agents MD, you will need to tell your AI to make sure to use those, because those things to avoid the repetitive boilerplate code. I always do the immutable test objects in all my projects where I already have predefined versions of all my entities. So in my tests, I can just reuse them and pass them around instead of like pre-creating them every time. And if I need to change like a couple of fields, I will change only a couple of fields, and that will make my test code much more readable. It will be clear which input I'm giving it, how is it different from average, let's say, and then like what is the outcome and why is it like that. And of course, I have that all, and then I get AI to generate my tests. Of course, it will always generate everything from scratch by default. So I was like very careful every time when I see that it's doing wrong, I would like add more lines to the memory file, like please do use that, please don't use do, to try to reuse as much as possible.
Yep.
And after like a few iterations, you finally get to the point where your junior developer assistant can actually do the stuff how it's supposed to be done. But the problem is that no agents will do all that by default. So unfortunately,
not yet. Yeah. Maybe I'm sure Google or Cloud Code, they will start incorporating more and more of these.
The problem is even the engineers, like
they have different values and principles, right?
And that's the problem. And you cannot. Sometimes it's even they are so deeply ingrained in some people. So like even if they are completely wrong, it's like the political discussions nowadays.
Yes.
No matter how much logic do you apply, people will still stick to their opinions.
And about, by the way, TDD, I just want to say, it's not like we're old guys and talking about TDD, but I want to just give one more example of people realizing the value of TDD in the age of AI. And if you know the Pragmatic Engineer, the newsletter by Gregory Oros, the guys, and he made a very interesting article on how Cloud Code team works. So the team that created Cloud Code. And I believe he interviewed or talked to Boris, maybe is his name, the main engineer in Cloud Code
Who was
team.
mostly tweeting about it.
Yes. And Boris, interesting insight in that newsletter, in that article, was that Boris realized that he uses TDD more and more, and his team started to use TDD more and more with Cloud Code. Because again, you have instant feedback loop, right? You're in the full control. You pretty much you do TDD loop, but now much faster with AI. You control the test, you implement it yourself, you tell AI to implement it. Now, given test, you can say to refactor it. And again, you have full control, but the speed of this red-green refactor cycle is now so much faster, right? And he also named it as the renaissance of TDD. So what I would encourage people listening here is, you don't have to maybe fall in love with TDD, but try it out with AI. Try it out, and I think you might like it, and you might see it as a powerful technique, because TDD really helps you with the design. By the way, the main thing is that it helps you create testable architecture, and feel free to create it with other means. But yeah, TDD just forces you to think as a client of the API, right? Whatever API you create, including whatever your functions, your public module. And then you just create testable components around it. So,
and also if you find yourself that it's very difficult to do the setup in your test, so that means that you're probably not having the right level of abstraction or not the right implementation of isolation, encapsulation, or whatever, how you call it. So basically, so ideally, if for the good code which is well designed, it's very easy to test. And that's why if you start from tests, it will influence your design and it will be much better in the end.
And if
with
there-
fewer dependencies in that sense.
And if there are any engineers who think like how to be relevant in this age, I would say learn TDD very well, learn then to do it in an AI assisted loop, right? Of course, learn system design, product engineering, and things like that in your domain, and then you're golden actually. Then you can work on the lowest level of, let's say, you have very fundamental skills that stay relevant, but now you're amplified by AI. And this is, by the way, where I want to talk with you, like this AI acting as amplifier, right? Like if you have bad practices, bad habits, AI will just amplify it, and you have
You'll have a lot of mess. If you had some mess, now you'll have a lot of mess.
And now if you have good habits and good practices, and now with AI, you can amplify it, and even better, you don't have to do boring parts anymore, but you still have good habits and good practices, and you are still guiding everything, controlling everything. I think control is very important here. You're in control of the code. You're in control of the code base. But yes, you're amplified by AI, and I think this is an important thing for people to realize. So yeah.
Related to tests, also, I saw some discussions on Twitter. People say also when DHH posts something about his Ruby love and Ruby on Rails and stuff. So there was a funny post which I find it true. It was comparison of different programming languages and how much tokens do they consume. So on average, so that is basically means like, yeah, with shorter, more concise syntax, you get it even easier for humans to read it and understand it quicker, and you're making it like saving your tokens when working with AI. And he was praising Ruby, and of course Python was relatively good, and of course some of the
because they were expressive.
Yeah, and some of the languages like Java, and especially
Go probably was later.
Go actually was pretty
good?
low. It was pretty bad.
Yeah, because Go has still a lot of boilerplate. Like if error doesn't equals to nil, return error. Things like
and that's actually bad, I think, for programming languages. When you choose one, you need to choose a more expressive one when you don't have so much noise. And Java, of course, is
I still like Go, by the
way. Maybe like I was teaching Java for a lot of my career and using it also. But Java itself as a language is probably not that bad, but it's not the best.
It's very verbose compared to Kotlin.
Very verbose, yeah. But how people use it is even worse. Is that it's just 10 times more verbose.
Getters, setters for everything, even if not needed.
So it's like terrible. And of course, and then I started also discussing with the people there regarding type safety. So some people say that type safety is also like a thing that like when you have to write up your types, that makes your code like more verbose. But in the other hand, it makes your code more safe. So there are some people who think that now AI will help you also to write code in a not type safe language, but still you need such a big and good code coverage, even for the basic things that you're like haven't forgotten some like comma somewhere. You need to write tests for everything in a dynamic language.
Do you want me to tell you a story about types?
Yeah.
So the story is the following: we were in the offsite in Marbella, and we were discussing. Well, now we are creating agentic architecture at Pactum and thinking how again make it agent native, right? How to help agent to navigate across our code base, right? And we were discussing types and schemas, right? So it's clear that schemas are not going anywhere, right? Because they help. Because the schema is about the insight. You know, as a human, what's the structure of this input or output, if you know, let's say in the cases where you know or define it yourself. And then, of course, you would want AI to know it very well. But then we realized is that, and by the way, kudos not to me, but it was one person named Matthias who gave this idea. But he said, very interesting thing. He said, well, we want AI not only know the schema of the thing, let's say something is foo, field is called foo of type string, and then bar of type int, but you also, with that, want to embed the semantic meaning of the fields. So ideally, you wanted to have in one file, one place, the schema and the semantic description of each field, what it means. And then if you look at it on the high level, AI will do so much more because we'll have more context. Of course, you can point to the documentation, but then you need to kind of architect it more and say, look at it there, look at it there. But whatever way you do it, I think it's important not only to have types, but even to have semantic meaning of each field, if you have it, right, if you know about it, and to engineer it in such a way. So we invented it and called it AI native typing with semantic field.
It's very funny. I think that goes into the long-standing discussion of where do we need comments in our code or not. So, and I think if you name your fields well, you don't need the descriptions.
And
I think it's going there. Of course, for some of the non-trivial things, you need to describe it. By my opinion, always has been that you need to name things well. And if you name things well, people will not mess them up, and the AI will not mess them up.
But I mean also like some properties. Imagine we still have documentation, like Stripe has documentation for API for a reason, right? It's not just like, hey, here's the schema, go figure it out intuitively. It doesn't work, right, like that. And I guess
it works like 90%. I think you need to describe a lot less than people sometimes describe in the documentation.
I guess the point is not to repeat yourself, right? You don't want to name something and just in description say what the field is. You want to describe the business context around it that matters, right? That would kind of augment the field and explain maybe some context around it, some meaning around it, like explaining the why it exists, or like...
Sometimes I agree that sometimes very rare cases that is needed. I think you should always prefer better names, which are self-descripted. So sometimes with pair programming, we could spend like, I don't know, 15 minutes, even half an hour arguing how to name something. And it's, of course, it's not always like that, but sometimes you need to spend this time, especially if it's like a central important part of your software. So it's very important to name something that it would be very clear what it is, and it won't be misused or misunderstood. Because even if you like add like a few paragraphs for every field, like nobody will bother reading that. People like nowadays, they don't...
By the way, about AI types and comments, I agree. The less, the better. Like all these verbose comments around. I think where it's useful is on the edges of the system, right? Especially the edges that you don't control, or imagine even if you have two different services and they communicate with each other inside a company, but still. I think so. This semantic meaning of fields is most useful on the edges, because that's where integrations usually break, or why integrations usually break and why people need integration testing is because their assumptions were wrong, right? Like they could have unit tested everything, but some assumptions were wrong. And I think that's where. But generally, I agree.
But it's better sometimes, very often actually, when I have to communicate to external API or whatever. I will map it into normal names, because very often, whatever API you're using, they're pretty bad with names.
So you have like your own anti-corruption layer, so to speak.
I usually introduce it, and pretty soon, because sometimes, of course, the API is really bad, and then you want to do it from the real start. But sometimes it's kind of mostly good, but some of the fields like have legacy or whatever reasons why they are named in a wrong way. So then it's better to rename it in your system, like map it in one place. And then throughout your code, you're operating with something that you control, you understand, and it's easy for you to refactor. So basically, AIs are still very bad at global refactoring. They're doing it very slowly, they skip stuff. So it's still, you need to use the normal IDE to refactor stuff, and it's still very important to rename stuff. If you see that something is confusing, go ahead and rename it right away, commit. Your next AI run will be happy about it.
I agree. I would say even more, I really liked about renaming. I want to even double down on this. It's important if in your team, you don't have the same understanding of the terminology, like align as soon as possible. So have in DDD lingo, it's called ubiquitous language, right? You want to align on the terms and then use it consistently throughout your code base, throughout when you communicate with PM, with others. You want your customers to understand you when you talk to them. And this is super important. This cannot be underestimated. And it's just like zooming out on your concept.
And I think that in that case, it's more important, like you don't have to describe every field in your schema. You need to describe probably the general relations of some entities in your system and what they are for, and then to have good namings after that, and I think you're done. You don't have to spend too much time on the documentation. So nowadays the problem is that it's too easy to let AI to generate boilerplate documentation that will just leave there, consume tokens, consume your mind and whatever. So it's still, we need to be very careful with AI when not to use it, or like when to keep it in control so that the output would be as small as possible. So it's still as important as it was always. Maybe even more important now. But going back like a couple of words about the type safety is that for the agent to work well and work...
They need types.
You need to have quick iterations, the quick way of realizing that that the step is done correctly.
And compile time error is the fastest way.
And compile time error is perfect for that. So actually defining your types, it's when I write, for example, there's like, if you compare it, like JavaScript and TypeScript is the perfect example, because you can write both. They essentially are at runtime exactly the same. But at compile time, you don't actually need to write a lot with TypeScript, a lot more, because most of the types actually are derived by the compiler automatically. So you don't have to declare everything. You only declare it sometimes. And with that, a little, how to say it, loss of the signal to noise ratio, you're gaining a lot of safety. And so it's like the same as with test-driven development or with tests. So there is like the first level of defense and the second level of defense, and third level is like the more like integration tests, which work with several systems, which are the slowest usually. You want the AI to be iterate as quickly as possible and learn the mistakes as quickly as possible. And for that, type safety is also really essential.
By the way, I agree. We are also in Pactum. I can see in the chats how engineers kind of discuss among themselves. We want to iterate pretty much on the AI speed. And for example, sometimes it checks the linting rules as well, but linting is slow. So we are now running it not on like each iteration, but like at the end of the step. But yes, you want to make sure that iteration speed is fast. And that, for example, linting doesn't take too much time, or other steps don't take too much time, because it all multiplies, right? And if you have like in each AI checking something, if it takes 1 second or 10 seconds, it's a huge difference, right? Or 1 second versus 5 seconds. And this actually matters. Yeah. And it mattered before AI in your normal cycle, but now it matters even more if you want to speed it up. I agree. What do you think of, by the way, I made a talk at PyCon on how I made it in November, and I wanted people to think more broadly about AI-assisted software engineering, and not just think about coding, but other tasks we do in software engineering. How do you see AI is changing other aspects of software engineering that we deal with?
Well, I would say that most things that I'm doing while software developing, I'm talking to people, I'm thinking, and then I'm coding. So the first two things, you cannot replace those, as we have already discussed. So what are the other things? The other things are generally, like in most cases, are useless. Like let's look at some examples. Like, okay, the code review is one thing, but yeah, you can use AI there to help you. I think it's better than a human review, because humans are not good at reviewing code. Then writing some useless documentation that nobody will read. Yeah, of course, AI will generate it well for you, but still the same old principles apply. So that before generating documentation, make sure who are you generating it for, and make it as concise as possible, because if it's going to be a human or AI reading it, still short matters and concise matters. So another thing is like, I don't know, bug fixing or like debugging. So that is actually a big part of the real engineering works when we're like having the live systems to maintain.
But AI can help a lot here, right?
Yeah, they can read. Actually, AI, I find it like before you needed to be very good at writing very good logs, so that you can read it and understand quickly what's happening there. So good traceability and everything. Right now, AI is somehow making it easier if you are bad at the other practices of the. You're having too verbose logs or something that AI can save your ass right now, because it will just read a bunch of unreadable stuff and find the important bits out of it. But still, that's expensive. It's still better to go and optimize your logs and make them less verbose and more to the point than to rely on AI like finding stuff for you. But of course, there is help there, and AI can sometimes find some funny bugs also pretty quickly.
I want to say we use AI for debugging, and we have in Slack we have our own Ralph, who is an AI assistant, and anyone can use Ralph. And even if non-technical person has some support question, they might even ask Ralph, because Ralph has a full context of our code base. They have access to our logs in Google Cloud, and they can go and kind of actually do at least what I call it a first pass. But sometimes, even if it's not useful for 20% of cases, what we see, it's very useful for 80% of cases, and that already has a huge value. So actually, debugging something, especially something that is rather easy to debug just by following the trace, we see a lot of value of this right now, and we kind of integrated it in Slack. So now we have Slack AI assistant who has again access to code base and logs, super useful.
But I think that actually a lot of bugs that for example, I catch from production, they are, I think, broadly go into two categories. One is that your assumptions were wrong with something, with external inputs, outputs, and that's, I think, is the most common one. And second one is some crazy technical things with like the something in parallel, like the race conditions or whatever, which are like which are really hard to debug and hard even for AI to solve. But with this second thing, I actually found that sometimes you can use AI as a conversation partner to actually find the cause.
And it can be your rubber duck, right?
Yeah.
It can, even if you don't, even if AI doesn't solve it itself autonomously 100%, you can augment yourself with AI pretty effectively to solve it together with AI, because AI can give you ideas what to check for, right?
But that goes back to the pair programmer, AI pair programmer, because that's exactly what you need it for. And the other bugs should be caught by the I don't know, compiler and whatever, also the pair programmer.
I'll tell you one more thing where we are, well, not only experimenting but fully adapting in production right now, very soon actually. We have our amazing head of design in Pactum. Her name is Brett, and we are now together creating a new design system at Pactum. But the whole point is that this design system will be agent native. So whatever front-end components we have, or whatever UX patterns we have, all will be available as context and as a skill for AI, so that whatever front-end is developed, at least the first pass will have our defaults of conventions, UX conventions, UI conventions, all our components, or even kind of higher level rules around those components. And I think this can be very powerful as well. It's a very powerful use of AI. And this is how we can bridge more the design and engineers together. And again, it doesn't mean that engineers don't have to think about UI, UX. On the contrary, I think engineers should think carefully and still control it, the full loop, and think about it very well, understand the domain. But I think the fact that AI can do the first pass and in 80% can do it pretty damn well, I think this is already very powerful. Where previously people had to copy things from Figma and implement it.
But you know what is fun? Like now with AI, people realize things that they should have been doing like their career. They were just too lazy to do those things. But now, because we have like a more powerful tool that requires a very good input, actually, we are now finally starting to do that. But if we were doing that for humans, humans would be so much more productive as well in the past.
I agree.
So, and
yeah, now we just have to like maybe do a small shifts to incorporate it in AI. So yeah, I think the companies that had very good habits around it, for them to make it agent native is actually might be very few steps. It might be like a one-day hackathon to just connect this all together.
Yeah, if you have basically all the important knowledge very concisely described somewhere, and you can feed it to AI, or you can feed it to people who can read it. For example, let's say a new engineer joins your team, they can spend like maybe a couple of hours and reading through all of it and becoming like already getting the context. That would help tremendously for both. I actually have an example of Kotlin language manual. Actually, it is very easy to go through it and read it all in a couple of days. The whole standard library, docs, and whatever, and that creates a context in your head to actually which features are there, and when you realize that you need some feature, you will most likely recall it and you will revisit it in the documentation, but you will have the context that it exists. And if you take, for example, the documentation of Java and
C++.
or C++ or the standard library, I think you would spend maybe a year like reading it all, and that is not very helpful because it's very hard to learn about all the possibilities. So I think it's very important to have the concise descriptions of everything, and then you can very easily give it to the AI, and they will also have it in their context. So context engineering, context compaction, context optimization. This is something that is becoming more and more important in the way forward. So this is how we will make it better. So when AI has a good context, it produces good outputs already now. We don't even need it to become better at it. What we need to become better is that how do we populate the context?
I agree. And we see the same at Pactum. It's 100% true, I think. And by the way, the same is for production users of AI, right? Like, at Pactum, we have actually AI systems in production that we develop, and we see the same. Like, I mean, a big part of this is not creating a prompt. Well, you have one prompt, what do you do next? Well, you optimize the context for it, and more importantly, you create very strong AI evals system, AI evaluations, to understand if this actually works at scale and works based on your data sets and other things. And maybe let's touch it a little bit, because I think it might be important skill for people and engineers who will create production AI systems. Like, do you want to discuss it maybe a little bit?
Of course.
Because I think it affects software engineering a little bit. For example, feedback loops and testing with AI systems. So maybe I want your take on how engineers maybe need to upskill to create very robust and useful, usable systems that sometimes have AI in the loop, right?
I think it all goes back to testing. So the same things that work for normal code. So what I find, I don't have too much experience with that, but I have built some systems where AI is used for the end user functionality. And then what I see, like a thing that probably can be named like a prompt rot or something like that. But it works exactly like the rot in any code which is you give to the hands of the junior engineer. They will always add a new if at the end and to make it do something else or improve it. And the same with context or with prompt rot is that you're always like adding more stuff to the prompt when you realize it's making mistakes, and your prompt also grows into something less manageable, and some rules that you add at the end, like they make de-emphasize the rules in the beginning, and you start getting regressions actually with adding more stuff there. So how to avoid it? The classical unit tests or evals, whatever, how do you call them? So basically, why not just write unit tests for your prompts, and you give it some known inputs, and you write down the outputs that you were getting before, and then you will have a more freedom of changing your prompt, because you can always rerun it on the tests and see like are there any regressions with the previous stuff.
The only one I would say I would add here, the only one difference is that sometimes your outputs, I mean, they might be deterministic for one input output, but the whole point is that sometimes you evaluate it not based on one input output, you evaluate it based on the whole data set. And then now you need to reason about accuracy, kind of precision, recall, maybe F1 score. And these are some skills that I would recommend engineers to just skill up on. And you could skill up on this in one day, right? Just read about these things. And because now you don't always act in this discrete manner, like true or false, but now you deal a little bit with you need to think about statistics, right? Of the what are your results based on this data set, and are you overfitting? Do you have a good sample of this? And I noticed that for some engineers, it's not the kind of second nature to do it because they haven't used this type of thinking. So it's just, I would say, a small shift compared to usual testing. From my perspective. But,
I think it's more comparable to maybe like the integration tests, because they are actually basically integration tests. So maybe like, yeah, to get to the final result, you can need to go through several steps, but still in the end, like all programming is about receiving data and like input and output basically.
But for example, imagine your AI processes some unstructured input and maps it into the structured output. And then sometimes it's okay if it's not, well, it depends on the application, but let's assume we have a use case where it might be okay if it gets it right 90% of the time because it provides business value, but it might be a disaster if it's only working for 50% of the time, right? So now you kind of have to think about percentages and then verify it with the product and think about, and again, it comes back to the domain understanding, like, do we understand that is 90% success okay for us and a good thing and we can ship it, or is it unacceptable because we are dealing with critical software system, right, where it should be 100%?
Well, it's very hard to even measure it and find is it 90% or not. So what I find still a good practice is that how do I approach testing of the external systems, or like writing tests for my code that is working with external systems, because the external systems is always unpredictable. We don't know like how it behaves. So in most cases, it's kind of the discoverability is that you actually you send some input, you get some output, then you record it. By recording, I mean in most cases you copy paste its output to your test and say, this is my input now. I want to process it, and I expect, and then I know what for this input. I know what the correct answer would be, and I record it as a test case.
There was like a wiremock, right, in Java or something.
You can use any tool for that. I would, in most cases, I would use just plain boring unit tests. So I just copy paste this content, say this is your input. What is my output? My output should be that in this input, and then I will. Evolve the system, so work on different inputs, outputs, and I will record more of those tests. And then if at some point the other system stops working or stops working like differently, I can always compare it with how it was before, because I have it all recorded as test cases. I can update those and run all the tests again and see if my code still works. I think the same way you should approach the prompts and the AI responses. Of course, they are fuzzy, but still you need to write down, record concrete examples where it was working at some point.
Yeah, absolutely.
So that you will not lose it.
No, I mean, what I meant by data sets is that you pretty much have them maintained, right? And you run them all the time in your whatever CI/CD or wherever you run them. So yeah, this is how we do it. You don't just run it, see it's 90% in production. So I was not talking about production observability. I was actually talking about having a highly maintained data set, let's say 100 samples. And then, because then when you change the prompt, right, if you have one sample, your level of confidence will be very low. But if you have 100 samples, which are, you hope, well represented, then your confidence grows. And then again, based on production data, you can add this back to your data set and make it even larger. So that, because the whole point, right, is that when you change a prompt, you want to make sure that your system does not regress, right, that it works well. So yeah. But
of course, and with those kind of unpredictable things in the middle as AI, actually you need to have much more tests than you would have for a normal code. So we would have those samples. And I think, I don't know, how do you measure it? Do you really, if you have your like 100 samples, do you really run them all and check that if like 90% of them pass?
Well,
I would
depends.
want 100%
Yeah.
of the recorded samples to pass.
Yeah, but sometimes you cannot do it. Sometimes it's not possible sometimes. And of course, now with the models getting better and better, you might. But that's the beauty. Like, you can see that it's 90%, but tomorrow a new Gemini model comes out, you check it, and now if it's 95%, it's no brainer just to swap the models, right? So, but of course, like sometimes the LLM use case will be so complex that it's pretty much, well, sometimes very hard for it to get it right all the time. It's almost like AI benchmarks, right? Like it doesn't get right all the time. It's the statistics. It gets it right on some things not. So even LLM models, they don't get it right on everything. So.
And I'm even not sure if the same LLM model will behave the same over time. If you're not running it yourself, probably like if you're using like external services of OpenAI, Google, whatever, for your running your models, like most people do actually. I think they are always like fine tuning to be more cost effective, and they are like actually making it worse over time. So the same model, I think you're thinking that you're making exactly the same query with the same model, but over time you can get worse results because they're like optimizing how they are compressing their context and doing whatever in between that you're not controlling
But
yourself.
I think new models still get better, right? Overall, as a
overall, yeah, I think so. They should.
But what I meant is that, imagine even if you have 95% success, then at least, you can even like change the prompt or think what to do to improve the result. And then you
but
you
I
have
think,
feedback.
if you have this samples, of course, you can be so much more in a safe position to actually change the model and evaluate different models and actually see like if there is like a 3 times less expensive model that can actually pass the same amount of tests. That's perfect.
And today there are also some frameworks that help you with that, because honestly there's quite a bit of boilerplate to do it yourself. You can do it yourself, but we use an open source framework called LangFuse for the like of like doing AI evals. But you can start easily just by doing it all yourself in code. And by the way, we are creating some minimalistic kind of assertion framework, whatever spec you write, like assert this equals to this, but you can kind of have the similar approach, but with less deterministic LLM outputs, where you just created a very declarative assertion library for this use cases. But
even in libraries like JUnit, like the classical stuff for testing, they had it for a long time.
Yeah, like fuzziness or
that you can put it like a bigger data set and it will run your test 100 times, and you can
Yeah.
define like the pass criteria. So it's actually exactly the same. It's not something that's completely new.
We talked for 1 hour, maybe more already. It's 7:50. What do you want to? And it's a work day, so no. But I do have time still. But do you want to touch some topic that is close to your heart still?
Let me think for a bit.
I can pour you more water if you want, or something.
I think it's okay. Actually, while discussing, I had some very good thoughts, but I lost it.
Oh no.
Maybe it will come back.
I mean,
but I don't know. The important thing is that the existential crisis. So we are like I don't believe that we're in the existential crisis. So there are so many people talking so much about that our profession is kind of is a dead end or something.
Existential crisis of profession.
Yeah.
I think if we follow these principles that anyone will need to architect this, control these systems, direct these systems, today, tomorrow, in 1 year, in 2 years, and all the software that is powering businesses, in this sense, software engineering job will just evolve, but it will not be dead if people evolve with this. So I think, of course, people who are super skeptical about AI and are not using it at all or not interested in this, I think they might get out of job because people will not want to hire these kind of people.
What I find also is interesting, there was some research on the creativity of AI. So we can, there was a lot of talk with that LLMs, they are getting the creative jobs. So they're generating music, they're generating images, designs, codes, whatever.
And we were told that humans will do creative stuff, and now.
But I found some research recently where they put the AI in the loop of, I think that they do it in also a funny way. So they actually created a prompt to generate an image. Then they asked the AI to actually to describe the image, and then put the description back into the image generator. And they gone through I don't know, a few hundred cycles. And in the end, they tried it many times. And in the end, it all deteriorated in very boring stuff.
Really?
That was really similar. I think they had a pretty big data set of very creative different situations at start. And I think they said that all of the images, they went into 4 very generic topics, and became really generic. So that is the problem, or that is, I think, how people nowadays actually recognize also the AI art, because it's kind of well made, but it's kind of boring. So also with the music and with the imagery on Facebook, you see posts, you most people will tell this is AI generated, because when you cannot recognize it, it means that somebody did a very creative, good work with the prompt to create a really nice new work of art or a piece, whatever.
I wanted to make a joke and say, I wish it generated boring code.
With the code, we can argue about that. Is boring code good or not?
I think it's good. I think boring code is good.
There is point of that, but with the this research, actually it proved that AI doesn't have the creativity of its own,
because it converges
at the current level, because it converges to something. So basically it only still, we should not forget that it's only it's a prediction statistical model that predicts text based on the stuff that it has seen and that you have given it. So in the end, it will not invent something new, and we still need the human brain for that so far.
It might invent, right? OpenAI is doing research how agents do science. I think there is but I think, that's more now LeCun school, where he wants to create these world models, right? Where they reason more, and tokens are not just text, but more physical things or other kind of dimensions, right? But I think researchers are experimenting how AI can do can do research, right?
Yeah, it can do probably, but still you need to feed it from time to time with something new. So I think this research still proves that currently you cannot expect anything creative. You can only expect a repetition of what already exists in the world. And that things AI is good. And that's what brings back the boring code theme, is that in fact, yes, boring code is good because people find it easy to understand, and AI also can produce it more easily, and it's easier to understand for AI also what it is doing. But we should not confuse boring code and boilerplate code.
Absolutely.
That is also an important thing, because when people say boring, very often they can mean a lot of different things.
Yeah, true.
And by boring, actually, we should probably define it as something that is straightforward. So
and cognitively easy to understand. Right?
So that there are no surprises in it hidden.
I
so
agree.
That is boring, and that is always was the good property of maintainable code.
True, I agree.
And actually, now I remember the thing, my thought that I had before, which is good. So let's talk about the dependencies.
Oh yeah, let's
do it. I was always actually telling people and teaching them to use as fewer dependencies as possible in your code. So people were overdoing that, and definitely adding a few more libraries, because you need just a few lines of code.
Let's talk about NPM.
Just try to do something. Yeah, let's talk about NPM or basically.
No, go ahead. Sorry. No.
And the thing is that with AI now, people say that the 2026 is the year of uh, vulnerabilities. So this is when it's so easy now to create exploits and execute them at scale. So there's a lot of open source code, even if nobody is like doing the supply chain attack and attacking you deliberately. If you're using like I don't know 400 different libraries, somebody will find vulnerabilities in them. I think right now we're speaking, there are probably a lot of automated scans going through and looking for the vulnerabilities that would be exploited automatically, and maybe tomorrow they will be exploited for you. So it always was a good idea to use as fewer dependencies as possible. Another thing why it's good is that you are learning something also. If you are not just trying to take everything ready-made and like compose something from that. And with AI, what I find is that AI very often as a first solution, it would offer you to use some very obscure library that you probably never used. Of course, it will offer you to use the most popular libraries, whether they are good or bad. Mostly they are bad because they do too many things, very popular libraries, and therefore they have a lot of potential vulnerabilities. But you need to be smart enough to ask AI to use fewer dependencies and not to add them as easily.
I agree. And this can be added in Agents MD or wherever you keep it in the system.
And with AI, it's so much easier. Like, for example, in front-end projects, I still see a lot of Lodash. There's Lodash everywhere. Lodash has been made obsolete by the standard library of JavaScript for 90%. And the other 10% is just a few functions that you need here and there. And most likely those functions can be written by you by hand in like, I don't know, let's say 5 lines of code, and they will be perfect. So you're like, it's very small increase in your like code bundle. But if you're even too lazy to write it like 10th time, you can of course always, before I was telling people just copy paste the function from the library. If you only need one function, just copy paste to your code and you will change it if you need to change it. But now you can use it, even AI for it. So for example, I don't use any localization libraries anymore in my front-end projects because I don't need them. I just import my translation JSON files as a TypeScript module. I get full code complete instantly and type safety from that. And sometimes I need like the fallback, for example, from the partly translated language into the English, whatever your default language is. And for example, you need to deep merge your like two data sets. And it's actually 3 lines of code always, but you can either copy paste it from your previous project or you can just ask AI, please write me this deep merge function. I actually tried it yesterday. Of course, first it put me like 20 lines of function, but I know as a senior developer, I know that it is achievable in 3 lines of code. So I would tell it like, make it shorter, make it simpler, and then it will follow what you're asking. But if you don't know what to ask or what to require from your AI or from your junior developer, then you will end up with more complex code or more dependencies. So,
by the way, I agree, and I want to even expand on this and add with dependencies, especially external dependencies. You have to be careful to allow the API of your external dependencies to propagate throughout your project. Because once you do it, and then if the library suddenly says, oh, look, we're not maintaining this version, we're doing the major change, and now the API changes, right? And now you are forced to change it in your project in all the 127 places. Okay, now it's easier with AI, but still, ideally, if you have a library and you know that, okay, let's assume you still are going to use it after careful deliberation. Maybe it's a security library, right? Maybe it's something else, crypto library, a complex thing. Then it's also a good idea to really evaluate how its API is going to propagate downstream and maybe wrap it into your own APIs, so that later you have to just change it in one place. If in case you need to update to the major version and update the interface, then you just change it in one place, and all your other inputs, outputs, and functions are stayed intact, right? So just a small, maybe, I don't know. What do you think of this practice?
I think the fewer dependencies you use, the less work you need to do with updating, upgrading, and maintaining anything. So yeah, I would even think like as a experiment, just try going completely like library framework free or dependency free.
Yes.
Of course, it's always okay. You will always need a compiler for some like any serious work, but still, like all the other like runtime dependencies, maybe you don't need them.
But I agree. And by the way, this is what I liked about Go it was such a fresh world after Java, because Go has this philosophy of as little dependencies as possible, and they have a very strong standard library. So like you need again HTTP server. You don't need any extra library for that.
Yeah, that's the strong part of Go, and definitely very weak part of Java, or the even JavaScript ecosystem, where for like everything you have like hundreds of bad implementations that people find popular. Like, don't let me start it on React or something.
Yeah, but may I ask you, maybe to slowly wrap up, but like going to this final phase of our discussion. Let's imagine you are CTO or VP of engineering of some company, and let's say your company, and you care that your engineering culture and organization works very well. What values, principles, and practices would you want to instill for engineers? Like, let's say if you had to write a one-pager, what would be the main, headlines, H2 headlines? What would they look like? Like, what kind of things would you stress on? Especially given today's change, what would be your message, and what kind of practices would you want to instill?
I think that hasn't changed and probably will not change, because when you talk about the fundamentals, they still stay the same. I think it's to have short feedback loops with everything. That's the most important thing that comes from the agile practices. So that is basically testing
on all levels, right?
Yeah, on all levels, but also with like frequent demos is also feedback loop, and
in the team, right?
Yeah, and showing it to your end customers, to product owners, and then also releasing it quicker for the end users, so you can gather feedback for some test groups and whatever. So it's all about the feedback loops. So the sooner you get your feedback, the better you can adapt and avoid unnecessary work. And collaboration, of course. So collaboration is also still important, even with the AI. So again, I don't believe that one person with 20 agents can replace. Maybe you can reduce like 20 person team into like 4 people with AI. I believe in that actually, but you will never want to go down to 1. I think that's pretty stupid for all kind of reasons, because
you have so much more synergy when
you will not be getting enough of the feedback of other people, like the other thoughts. You will not creative thoughts that AI is not doing right now. And you will burn out, or you will become ill or something. And
so there's also the resiliency aspect, right?
Yeah, they will be in trouble. So usually, you never want anyone to be this single person knowing something or like good at something.
Don't have single point of failure, right?
Yeah. That's I think important when building the teams. So
I agree, by the way, with this.
Well, and the productivity, I would I would teach people to keep things simple. So that's what people are very bad at, unfortunately. Everyone tries to over-engineer. So I think, again, the old agile practice of actually postponing any big decisions as much as you can. So you're building it at every step. You're finding the simplest possible solution that would possibly work. And then after like iterating it and getting your feedback, you know where to direct it, the complexity. It's so easy to create complexity, it's so hard to get rid of it.
Kent Beck, by the way, names it. He has this new book, Tidy First. I don't know if you read it or not. It's 100 pages, very small one. But he calls this aspect optionality. Like you want to, how you delay decisions is that you create optionality for you to make this decision later, so that you try to keep your options open, right?
Yeah.
And then, of course, by not over-engineering the system, but keeping it simple, but knowing like how to keep this optionality high, so that you can adapt to because the truth is, you won't know the business needs of like next month, but you want to be able to adapt to it and keep your options open.
And that also means that you need to have your design, like your code designed in a modular way. So this is what also AI will not do for you by default.
By default, yeah.
And you need to like strive for it. You need to teach it to do, and you need to teach people to do, so that related things are together, unrelated things are as separate as possible. So you
cohesion,
can,
right?
yeah. So you can replace them separately very easily. So that is the most important thing, to keep the system evolving for many years, because most software systems, they outlive a single engineer working on that system. So if the system is commercially successful, it will always outlive.
And they literally outlive person.
Yeah, they can outlive a person even in terms of them dying, but they mostly outlive people just quitting and changing jobs. And then you need to have it like very modular, so that different people can work and focus on different aspects of it without interfering with each other.
And we need to keep this property, pretty much everything you said, but we need to keep this property so high that keep system evolving for a long time. As ever, it's more important with AI, because one thing we see with AI, sometimes if you're not careful enough, it's easier to pick up bad habits, just to create what's called AI slop, right?
Yeah, and as you said, like AI will amplify any bad habits that you have, and you will get unmaintainable state very, very quickly. Before it maybe took years, now you can get half a year.
Not even 1 week, right?
Yeah, you will sink your ship.
But it's true. It's true. Yeah.
But what as a CTO or whatever now, I'm so surprised in that I cannot estimate the team size that I need. Actually, I have a few job offers for CTO right now, and then I'm thinking like, how many people will I need to like
succeed
to succeed with that or that project? Before I would have an idea more or less, but now like I don't know where AI is evolving and how much it can boost. So far, I'm very conservative at that. I'm pretty surprised that you have so many people in Pactum. Probably not all of them are engineers, but what I have seen throughout my career is that fewer people do better quality job than more people.
Yes.
With more people, you always get human slop.
No, I can explain how we are. So we are around 40, maybe now 40. Let's assume 40 to 45 engineers, just to have a like order of magnitude comparison. So 45 engineers, but we are in the procurement space, and in our case, what we try to do is that. For you to understand, we have quite a few subdomains. So we have actually a few product verticals that are fully different, and like you need to immerse into that, and they're like different business contexts. For example, direct spend versus indirect spend, and then they're like and we have another world of, for example, integration landscape in procurement. That's huge. There's like SAP, if you heard of the company, that's crazy. There's
they probably
Coupa.
have thousands of engineers.
Yeah. But we need some engineers. For example, like we have a team who thinks about integrations only. We have different teams, but I like the, by the way, I have here Team Topologies, amazing book, by the way. And it talks about this Dunbar number, or I think it's called that way. But like, what's the effective size of the team and interactions? But yeah, we try to keep the team not more, recently, by the way, I made one more split of the team because the team was quite large, already 10, 11 people. And we split it, we found the subdomain, the seam, right? Like what the business seam. Like we found a very clear decoupled, loosely coupled thing that the team can have, a separate team owning their own business metrics end to end, and working on that. And this is very important. So, and this team right now is like four people, actually, 3 engineers, and we're still hiring PM. Very small team. Some teams are a bit larger. They're like 7 people maintaining many customers. But yes, you try to still divide and conquer, and try to make sure that you don't have this kind of, like in software, we have God object anti-pattern, where we have this like one huge team. Because you want to keep the subdomain in such a way of the team that they can think full time about it and become experts. Because the larger the team, the more you kind of become mediocre in everything, because you cannot think about everything and all the business context. But yeah, we have data scientists, we have engineers, and others. And now we are, you probably know, we raised a lot of money, but now we 50 million to be clear. But now we are only hiring, I think, in 2026. Well, I won't say for 2026, especially on camera, but let's say right now, as the next step for a few months, we decided to hire only 4 to 5 engineers more. And then maybe we will reevaluate in the second part of 2026. But right now, we don't want just to go and skyrocket in terms of hiring. So now, we keep the bar high. We try to hire the best engineers, but not so much. So we don't want to grow 2x in terms of engineers, because as you say, you're right. It's very hard to guess how much you can you have some empirical evidence. We do see like how some people can be effective, but I think part of the answer is, by the way, who you will have in your team, because you might have 4 people who are senior engineers and they know and are curious how to use AI to amplify them, or you could have 4 engineers who are not curious about it. They won't learn about AI and they'll be like, no, we're going everything old way. Then I think you won't have this amplification effect. So I think you need very smart people who have strong fundamentals and then actually optimize their workflows with AI. And that can be powerful, I think. And this is one thing we have now as a principle in Pactum. We're really making it clear for all engineers and everyone who we hire that on top of fundamentals that should be very solid, you need to be AI curious, and you need to be able to learn, experiment, and evolve your workflows with AI.
But also actually talking about skills, like we did in the beginning, I think what is right now matters a lot is that specialized knowledge gets very unimportant.
Domain specific.
No, I mean like if you're very specializing on into
like front end versus back end. Yeah, for sure.
Yeah,
I
for
agree.
example, so if you're very
let's discuss that. Full stack front end versus back end.
If you're very narrowly specializing on something, that doesn't make sense anymore. So
by the way, I agree, and we don't hire this kind of people right now.
It never made sense, but it was very popular, still very popular with people specializing. But now with AI, it gives you ability to actually to operate in any framework, understanding how it should work.
I agree,
and that's important.
I even had this principle before AI, but I think now it's as important as ever. If before, maybe for some very specific cases you needed like one front-end engineer or one back-end engineer, and again, I was against this approach coming from Wise, right, where we all had product engineers. It was even true 10 years ago when I joined, or like 15 years ago. And I think now it's even more true. Like we want to hire only I think not only we as Pactum, but industry, I think, wants to hire only strong, well-rounded engineers who can solve problems end to end.
Hopefully. I think if we open any job offers right now, you will still find some React developer and Spring developer.
Yes. And that's weird. For me, that's very weird.
And I think, it doesn't make sense anymore. But it means that the state of the industry right now is very split. So there are some going like very all in, and some are like very, very conservative about that. But also like over engineering. So if we are talking about the team size, it's very easy to overhire, and it's you will most likely will not realize that, because people will always invent work with AI or without AI. If there are too many people, they will be inventing work that is not needed, and they will be doing that.
But that comes to product engineering culture. I think if you hire really strong product engineers, let's say, who have options, who have stake in the company, and they are really interested for the company to succeed, like truly, then they will be very careful about this, like what they're working on. But this requires a certain culture to really find such people, and I think this is now the responsibility of engineering leadership, exactly to define this hiring needs and be careful about it, and not over, as you say, overhire, and be very clear about priorities, business priorities. And
I think like regarding the business things, of course, sometimes you can have like a long backlog of the ideas that you want to test on the market, and maybe having more people you will be able to like parallel it all and do it all like more quickly. But still there are some natural cycles that you cannot like speed up. Like for example, if you like bring a new feature to the market, you still need some time to see if anyone needs it or not. And then like if you're just delivering more and more and like making like for example some system that you want people to use like over complicated in terms of features, you will still get nowhere. Like look at the
I agree.
AWS. It's like so overcomplicated with everything you're there. It's just overwhelming. You take any other like many other like simpler competitors and like wow, they're like 10 menu items in the cloud provider and they all make sense. Wow, that's such a cool thing, because like you need to focus on the things that matters, not like create everything. And that's the same thing with simplicity versus complexity. It's easier to go the complex route and like create something like more code than you actually need. And it's also easy to put too many people and they will be creating this complexity, because otherwise they would be just sitting there doing nothing. And with AI even more. So I would say that for me, like over a long time, I think the ideal team size working on something isolated enough is four people.
Yeah,
I think four people can achieve a lot, even without the AI, if they're
and we can see that as well.
doing the work efficiently. And you always need to start with smaller number even. So at Codeborn, I think I would mostly tell in my customers also like let's start with one pair, like two people.
Yeah.
Then after
and
months,
they can adapt, right?
Yeah. Then after months, let's add another pair.
And you learn the domain and you understand, do we have subdomains to kind of really parallelize
and after that we can add more, but in most cases you don't need, because
I agree.
Because a team of 4 people can usually move so fast that all the other people working with business, marketing, whatever, they cannot keep up.
Yes.
And then it's the answer, like, do you need to hire more people or not? But if you initially put 10 developers, of course, they will be creating just more code that you don't need. And nobody will be realizing that. So it's very hard to understand if you have too many. It's easier to understand if you have too few, and then you can act.
Yes, I agree. It's easy to understand if you have too few. I think you understand if you have too few. Still, like I'm operating on a level where you need to make some business bets as well. But sometimes if you are in the industry and you understand that if you don't do this, you'll be outrun by competition, and you really have the window of opportunity of half a year, not more, to capture some customers, you need to make some bets, so to speak. But let's say if you make a bet to work on some subdomain, right, like some specific problem, exactly, don't put 20 people on it, put 4 people on it. So if you need to go into the new avenue, yes, create a highly performing team and let them operate autonomously end to end, and not put like 20 people on it, but put 4 people on it, let them, and define the business scope for them, define the first success kind of MVP or criteria for them, and then let them learn. And honestly, we had a similar approach. We had one new business direction which we went into, and I believe we put in the beginning 3 people on it. And they delivered it successfully. Like they delivered the solution for 2 Fortune 500 clients that we had. It was successful, and then we realized, okay, we need to hire 1 more, right? And we started because we realized that we understood the scope, we understood the domain, we had a success story. So I think you can kind of make these bets, but make a kind of highly autonomous team working on it. But yeah, that's where it gets art and science. But yeah.
Another maybe small topic, maybe we should...
No, you can go ahead, and then we will wrap up on this.
There were a lot of talks recently about the platform teams also, like to have the platform team, but basically when you're creating a platform team, like with DevOps people, whatever, they will become the centralized nightmare. They can make all the other teams slow down. So they will be creating some infrastructure for the others that kind of makes sense to have more homogeneous infrastructure if you have like a bigger amount of teams actually on in your organization. But the platform team is the one often that I find, like if you're a highly focused team, like of 4 people working on some
you don't want to be stopped
complete
by a platform
domain,
team.
and there will be somebody stopping you from upgrading your dependencies
Yes.
or whatever because they haven't been verified for everyone. So there need to be a technical autonomy also. It should be as homogeneous as possible. But if you need to change something, if you need to do it differently, only maybe for some time, you need to be free to do that, so that you're not stopped by stuff.
I agree. I think what platform teams can enable, and by the team topologies book also talks about it quite a lot, and the anti-patterns of platform team when it becomes a single point of bottleneck, let's say. Yeah. But I think you can devise it carefully. My principle that I try to follow is say, if you need something and you still as a team, let's say as a product team, I'm okay to do it in a homogeneous way. I see platform doesn't have capacity for it. We could go into their code base and with consulting with them a bit, implement it ourselves, let them maybe review quickly and then move ahead, right? So if you still have some conventions, you want to follow those, for example, but the whole point is that you will not be blocked by the team, right? You can go ahead there and do it by their rules, so to speak, but they will help you out and they will not block you. And they will not tell you, we'll come back to you in a week. No, if the team needs it this week, you will go and help them do it themselves, but you will just be in a consultancy role, right? And just reviewer role. So I think this pattern sometimes also helps, and this mindset, that in no way platform can block the product teams. So if they want to implement something themselves, there's also a rule of 3. Do you know it? Like you implement it once yourself. Second time you implement it also yourself, but the third time you will platformize the feature, so to speak, because now you have kind of 3 points of comparison, and you can kind of see what's a triangulation pretty much, but now you platformize it. So I think it's also a good rule to follow. But Anton, what would be your some wrapping statements about AI transformation in software engineering? Anything else you want to say on the end?
I want to say to junior developers that our profession most likely will change a lot. It already changed a lot, and but it will not go away for sure. So yeah. But I still think that we will need fewer software engineers than we used to have, or maybe we will be creating more. So that has always happened also in humanity. So when we get new technology to make something more efficient, we just find more work and create more. So that's also an option. So that makes our jobs safe, let's say. But and for junior engineers, you need to learn the fundamentals. You need to learn how stuff works, and then you will use AI to help you write the syntax and use AI as a somehow as somebody, as advisor, just talk to it, ask what is the best way to do it? Is there any other way to do it? Maybe it will can point you to some other direction if you don't have this context in your head already as a senior engineer. So I'm really worried about actually the junior developers and how they will actually learn what we have learned, because it will be so easy for them to just skip the hard work and just go the easy way. But I also think that those people will not be very useful in the future, who are skipping it and doing the easy way. So still, to learn something, you still need to invest in that, and it will stay true.
And I want to bring good news to more junior engineers, is that, well, for example, companies like Pactum, we do hire junior engineers. And we did hire, in fact, very smart and bright junior engineers recently. In fact, around 4 people, which is still quite a lot. Recently, we had a streak of hiring juniors. But we hired strong juniors who are very good end-to-end problem solvers, who had very good what we call product aptitude. They can, talk to clients. They are curious about our domain, and they had good fundamentals. They still have a very strong abstract reasoning skills. They can program very well. and let's say, well, in system design, let's say they don't have to know everything as seniors, but they know some basics and they're ready to learn and grow further. So, so I think the market is there for such people, but you have to, not cheat and not skip on the basics. I would even add on top of it, if you really want to differentiate yourself, think about end-to-end skills that will help you in end-to-end problem solving, like data analysis and data science skills. Because actually, if you think about now that you're in some domain, you will need to analyze some data, right? In some case, and knowing like even the basic statistics or being able to basically analyze the data. Of course, you can start with simple things and then go into more details like data science. But even simple things will can get you far, because then you get more autonomous in terms of end-to-end problem solving skills. So there are many ways how to differentiate yourself. So just think how to become effective end-to-end problem solver. But yes, for engineering, there is no cheat code in terms of maintaining systems for a long time. There you need to know fundamentals.
But also, like, I had this idea right now that maybe this AI transformation will actually bring back the cool old times when all the developers were actually fans of what they were doing. Then at some point, the programming became so like democratized, which is in a good way, but also in a bad way, is that the average level of the developers dropped significantly. And now maybe it will like a little bit bring us back to the old days when
I think
people
so, by the way.
who are dealing with that, they are really good at it. And maybe we don't need people who are not good at it.
I agree. I think we will have, I call it high pass filter, right? We will have this high pass filter for sure. And that's a good thing. I think that's a good thing for economy because, well, we will have people who will do their work very effectively. And I think that's good for economy, actually. My opinion, I don't know. What do you think?
Yeah, I also think. And it's also good for maybe the happiness overall of people working in an industry, because then you can work with smarter people, you can like achieve more and like overall.
And there's, by the way, though, one more thing before we wrap up. They say that intensity of work actually gets higher with AI because you have to make more amount of strategic decisions per unit of time because the loops are so much faster. And it's actually, how to say, energy consuming, right? Because now you have to all the time think about strategic thinking. Like, before you wrote a for loop and you did it kind of on autopilot and you were like waiting maybe for the things to compile. But now the amount of strategic decisions each person does grows.
And so some people envision that our working day will shrink. So a lot of developers were complaining already like long time ago that, I don't know, they can do only like 4 or 5 productive hours per day. I think maybe it will become a reality which will lead to better quality of life.
It could.
So,
but it would be very cool to talk in 1 year and see where our industry is in 1 year.
Yeah, everything's changing
thanks,
so
Anton.
fast. Yeah.
Yes. Oh, that was long.